So the sum of the terms in an arithmetic sequence is called an arithmetic series. So, find the sum of 1 plus 2 plus 3 plus 4 plus blah 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 plus 97 plus 98 plus 99 plus 100. So, does anybody think they know the answer? Yes, how did you get it? Okay. So what did you get? It's 5,050. You see here I have a hint. Pair off the numbers in a special way. Okay, so yes. So 1 to the 99, 2 to the 98, 3 to the 97. Okay, so how many would we have of those? Okay, so here's the thing. When you count from 1 to 5, how many do you have? You have 5, you don't have 4, right? Yes? So say that again, what? You have 49, yeah. Okay, so how many 49s do we have? I mean, how many 100s do we have? We have 49 of them. 49 100s? See, and I would have paired it up as 1 plus 100, 2 plus 99, 3 plus 98. Then you have a whole bunch of 101s. Okay, that's fine. We could do it this way. Okay, but here's the thing. From 1 to 100, how many do we have? Okay, I will repeat. If we go from 1 to 5, how many do we have? 5. So how many would we have if we went from 1 to 100? So if I pair up 1 and 99, we'd have an odd number of pairings in there, right? Do you see what I'm saying? So let's try the 101. Whoops. Okay, let's try a different pairing. 1 and 101. 2 and 99, 3 and 98, those add up to 101. And how many would we have of those? 50. So if I take 50 of them and times it by 101, I will get the correct answer of 50. So does everybody see why we had 50 of them? There's 100 numbers, and if you put them in pairs, you'll have 50 pairs, and each of the pairs add up to 101. So doing it, although I really like the 1 and 99 and you got 100, you had that leftover one. You'd have to figure out what that leftover one would be. So it would work, you just have to remember to add it on later, right? Okay, so yes, we get 50. So now, if we looked at this, do you think you could come up with a formula of, of how to come up with this arithmetic sum? Well, what does the 50 represent? The amount of pairs. So how did I figure that out? The number of terms divided by 2. Very good. We're getting there. And what was the 101?
Q1 plus T.
It was a sum of each pair, but because we might not know each pair, let's narrow it down to one pair that we know. The first and the last. Very good. This would be T1 plus Tn, whatever the last one is. Yes. N divided by 2. Okay, so you can either write it as n over 2 times T1 plus Tn, or you can write it as n times t1 plus tn all over 2. But I think this way you actually understand what's happening here, that you're taking the number of pairs and timesing it by the sum of the pairs, right? So Sn is the sum of n terms of a sequence. N is the number of terms being added. T1, of course, is the value of the first term. And Tn is the value of the nth term. And in all our cases, the nth term would be the last term because we have to end it to actually add up something, right? Okay, so remembering that our first formula had Tn equals T1 plus n minus 1 times d, we could actually substitute Tn in there and get a new formula. Let's do it. It's algebra. Math is fun, right? Okay. Okay, so we're substituting this, just so you know what I'm doing here. We're substituting this into that. Okay? Can we do this? Okay, so Sn is equal to n over 2. Instead of instead of Tn, we're going to write T1 plus n minus 1 times d. Does everybody see what I did there? Because I'm replacing this Tn with that from the first day's stuff. Okay, can we add something together here? T1 and T1 is 2 T1s. So 2 T1 plus n minus 1 times d. We're not going to simplify it anymore. So if you want, we can write it like this. And again, you'll be given both formulas. You don't have to memorize this. Okay. The only time I've ever... Okay, so let's add this up. Now I know you could, there's only like 5 terms here. We could just add it up in our head pretty much. So let's do this by hand and then use our formula just to prove that we would get the same. So 2 and 5 make 7. 7 and 8 make 15. 15 and 11 make 26, and 26 and 14 make 40. Okay, so now let's use the formula this time. The formula is, how many terms are there? 1, 2, 3, 4, 5. So we're finding the sum of 5 terms. So we are going to take n, which is 5, divided by 2, and times it by the first plus the last, which is 2 and 14 makes 16. So using mental math without a calculator, does everybody see, instead of going 5 divided by 2, we could actually cross cancel 2 and 16. So it's 5 times 8, which is 40. Because this is 16 over 1, we can do a cross cancel. I showed you those before. Yes? Oh my gosh. Okay, so now we're not going to actually take our calculator and add up 1 through 51. We're going to use our formula. So how many terms are 1 through 51? 51. So we're finding S of 51. So 51 terms divided by 2. And what's the first plus the last? 52. Again, you can do a cross cancel, but you still probably want your calculator because then you still have to do 26 times 51. So anyways, what do you get? What do you get? Yes, 1,326. Okay, do you guys want to try the last one? What's wrong with the last one? Huh? We don't know how many terms there are. Darn it! How could we figure that out? Do we have to use our fingers? No, we don't use our fingers. We have the magic of algebra. Do you remember that formula from yesterday? Okay. What's our last term? 50. What's our first term? 6, or value, I should say. We don't know what n is, so we're going to leave it as n minus 1. But we do know what d is, and what is d? 4. And this is not add 4, this is multiply 4. So now I'm going to actually multiply that in, so I get 50 equals 6 plus 4n minus 4. 6 minus 4 is 2. Move it over. It's 48 equals 4n, so n equals 12. So I know that there's 12 terms that I'm now going to add up. So we need to find the sum of 12 terms. So the sum of 12 terms is 12 divided by 2. Take the first term, which is 6, add the last term, which is 50. And 6 times 56 is 336. Find the sum of 12, 16, 20, 64. So what do you think you have to do first? Find n. So find n. So first thing you have to do is find what n is. So I'm subbing it in. Tn equals t1 plus n minus 1 times d. So 64 equals 12 plus n minus 1. What's the common difference here? You're going up by 4, right? So 64 equals 12 plus 4n minus 4. 12 minus 4 is 8. Move it over. We get 56. So n equals 14. So there's your first kind of points. Then we got to find the sum of 14 terms. So that is 14 divided by 2, 12 plus 64. So that's 7 times whatever, it's 532. Okay. So why is example 3 a little bit more challenging? You got to do a lot of stuff. So, what do you have to find out first? Yeah, okay, so you might say you don't know what the last term is. However, before you can find the last term, you have to use this formula to find d. So what you're doing is you're using this to find d. Once you know what d is, you continue the sequence to 22 terms. If you want, you can find the 22nd term, but remember I have that other formula that does not use the last term. It uses just the number of terms, right? And then you can use this formula now. You see what I'm saying? So you could use the above formula to do this, but then you'd have to figure out what the last term value was. Yeah, and you'll get the same answer, right? Because if you remember, the way I got this formula was basically using this formula with this formula, right? So I'll give you a second to finish that one. So to find d, I'm going to sub it in. Tn equals t1 plus n minus 1 times d. I know it's the 9th term, so it's going to be 31 equals the first term plus 9 minus 1 would be 8d. The reason why is I'm using that n is 9 when I'm finding d. So subtract 7 over, I get 24 equals 8d. So d is 3. So there's your first point by getting d is 3. Everybody good with that one? So So after I find D, I can use the second formula, Sn equals n over 2t1 plus n minus 1 times D. Now the reason why I'm using the second formula is if I want to use the first sum formula, I need to know what the last term value is, and I don't know what that is. So you could figure it out using this formula, but why, right? When you have another formula. So S22 equals 22 divided by 2. 2 times the first term is going to be 14 plus 22 minus 1 is 21 times 3. So if I punch all that in, what do I get here? 847. Any questions there? So find the sum of the first 20 terms. So it's going up by 3. I know D is 3. I know the first term is 3. I don't know the last term, but I know n is 20. So which formula should I use to be more efficient? The second one. So S20 equals, there is 20 divided by 2. 2 times the first term would be 6 plus n minus 1 would be 19 times 3. Yes? And if I punch that all in, I get 630. Did you get 630? Okay, why don't you try the next one using the same formula then? It's going up by 1.2, right? It just so happens the first term and the difference are the same things again. So we're finding S15. Twice the first term would be 2.4 plus n minus 1 would be 14 times the common difference is 1.2. So you should get 144 for that when you punch it all in. Alrighty. Last example, example 5. This is a good one. You definitely get calculators on this test. Yes. That's a gimme. Yeah. Yeah. Do you know what multiples of 6 mean?
6 times what shows that number.
Yeah, yeah. It's almost like saying factors that have 6 in it. So would 100 be a multiple of 6? No. So what's the first multiple of 6 after 100? 102 is the first one. Okay, do we need to know the second one? Or does anybody know the fast trick to know the next one? Instead of going 103 divided by 6, 104 divided, you just add 6. Yeah. So add, so plus, because I'm finding the sum. So add 6, so I get 108 plus blah, blah, blah. So I do need to find the last term because otherwise I don't know how many n's there are, right? Because I'm missing the n's and I'm missing the d's. So, but I could find the last term. Start at 500 and divide by 6. Does it work? Start at 499. Huh? Yes. For 6, it has to be even, and it has to add up to something that 3 goes into. 498. So if you take that logic, 498 works. If you add this up, you get 21, which is divisible by 3, right? So 102, that was divisible by 1 and 2 is 3, and 3 is divisible by 3. And it has to be an even number for 6, because the even number has to do with the 2 being a factor, right? Okay, so now we know the first term, we know the last term, we know the common difference. What don't we know? We don't know how many. So how do we figure that out? No, you don't guess. we use the formula. It's always a formula. That's what's so nice about this unit. It's just formulas on top of formulas. So, first term is 102. The common difference is 6. Tn is 498, but we don't know what n is. So we're going to use the formula Tn equals T1 plus n minus 1 times d. So Tn is 498. Term 1 is 102. N we don't know, so we have to leave it as n minus 1, but d we know is 6. So 498 equals 102 plus 6n minus 6. If I take 102 and subtract 6, I get 96. If I subtract 96 to get it over to the other side, I get 402 equals 6n. And does everybody know how to divide 6 really fast? Well, don't be doing long division. You just go, 6 goes into 40 how many times? 6, and there's a 4 that's a remainder, and then 6 goes into 42 7 times. You see how I did that? I was kind of covering my, right there. So, now that we know n is 67, we're adding 67 terms. So which formula am I going to use for Sn? The first one, because we know the last value and the first value, right? So n divided by 2, T1 plus Tn. So the sum of 67 terms is 67 divided by 2. The first term is 102. The last term is 498. And we get, what do we get? A big number. Yeah, 20,100 is correct.